Hello, everybody, and welcome back to another episode of Bo Maths. I'm your host, Bo Maths, aka Nuptial Failures, and today we are going to be doing some crazy probability. Behind me, you will see a little bit of a probability machine, if you want to call it, that I've designed. And even further behind me, that was from a previous episode, and so is up there. You can check those out if you're curious. But today, we are going to be looking into some of the game's probabilities, specifically regarding mob drops. Now, if you go into the Minecraft wiki where it says drops, you'll be able to find all sorts of information on here. And really quickly about the way it works is along the side you have all of these different mobs, these different kind of creatures that you'll encounter in the game, and on the side it has common drops. So these are what they drop when they die, when you kill them. So for example, if you kill a creeper, it drops 0 to 2 gunpowder. So what this 0 to 2 means is that it has an equal chance of getting 0 as 1 as 2. So any of those have the same chance of happening. So you could either get no gunpowder, 1 gunpowder, or 2 gunpowder from a creeper. So that means there are 3 total outcomes, right? 1, 2, or 3. So because it's the same likelihood for all 3, for no gunpowder, there's a 1 in 3 chance. For 1 gunpowder, there's a 1 in 3 chance. And for 2 gunpowder, there's a 1 in 3 chance. And notice that if we add all of these probabilities together, a third plus a third plus a third, we end up getting 1. Which makes sense because 1 is 100%. That's all of our possibilities here, right? So these are all of the outcomes for getting gunpowder. And so for all of these common drops, this is just how it's structured, right? So for example, so for a slime, you could get 0 to 2 slime balls, right? So that's how you read kind of this column. You just look at the range they give you and understand that all the numbers in that range have the same chance of occurring. Now, on the right here, we have rare drops, which are essentially drops that aren't evenly distributed like we have with the common drops. So for example, with the zombie, which is what we're going to be looking at in just a little bit, there's a 2.5% chance to drop either an iron ingot, a carrot, or a potato. So this is a lot lower of a chance, right? This is meant to be a rare drop. Only 2.5% of the time you're actually going to get one of these items. So hopefully that gives you just a quick rough idea on how to read these charts for yourselves. I encourage you to go onto the website. I'm going to provide the link in the description and you can kind of have a perusal through these to learn kind of what all the different rates are for yourself. Now when it comes to me just being told things, right, like that this is the probability, I'm always a little bit skeptical. I mean, why is that the case? I like to find out things for myself. I like to understand things for myself. And so I thought, hey, why just take them at their word? Even though, yes, you could go into the game code and actually verify that those are the chances, why just take them at their word? Why not experimentally verify it? So that is what this is right here. So this device here is going to summon in tons of different zombies. And with zombies, we could get no flesh, 1 flesh, or 2 flesh. Right, so that was the 0 to 2 range. And each of these, because there's 3 different outcomes, have a 1 in 3 chance of occurring, which is 33.3 repeating percent. Furthermore, there's a rare drop of iron, carrot, or potato, and this happens at 2.5% chance. So this is what the website is telling us. I want to actually verify this. And that is what this is going to do. So what this device is going to do is it's going to kill a bunch of zombies and keep track of how many had each different type of drop. How many zombies dropped nothing, how many zombies dropped 1 flesh, 2 flesh, and so on and so forth. But before we get into this, and I am going to explain to you exactly how this works because I think it's important to understand how things work. Of course, if you're not interested, you could just skip to the timestamp where we actually go through the kind of the testing with this thing. But if you are interested, I'm going to explain how this works in just a moment. Before we do that though, just in case some of you aren't super comfortable with redstone stuff, I am going to be explaining how a few different preliminary aspects work. So here we've just got some basic components of redstone, and then this is an item filter, and this is an item elevator. So if you're not comfortable with any of these aspects, I recommend you watching this next section. But if you're good to skip over it, then just skip to the section that is about actually building this contraption here. The observer. I hardly know her. This device here is called an observer, and essentially what an observer does is it observes the block in front of it, and it detects any sort of update in the state of the block in front of it. So if you put a block here, it outputs a signal in behind. If you break a block, it outputs a signal, because anything you do here, that is changing the state of the block, right? So you could even have something like a crop growing here, and that would, once that crop grows a little bit, that would update the block state, and that would send a signal through. So that's how an observer works. Redstone torch. Over here, we've got a redstone torch. By default, it outputs a signal. You can see that it has this lamp on here, right? If I broke the torch, the lamp would be off. But if you send power into a torch, that basically negates the signal and turns it off. So torches by default are on, but they can be switched off by putting power into the torch. Hopper. I hardly know her. The next piece that we're going to be looking at is a hopper. Hoppers, they basically just take items from the inventory above it. So I could put like a redstone torch in there, and it basically pulls it through, and you see where that little lip is facing into kind of the inventory that is next to it. So in this case, it put it in here. And don't worry about all this stuff. But hoppers also can just suck up things that are just on top of them from above. You see that redstone torch disappeared because it went into the hopper here. Comparator. I hardly know. The next piece of machinery we're going to need to understand is the redstone comparator. So this can do a few different things, but the aspect of it that we're using today is just simply its compare mode. So what it does is it can be used for a lot of different things, but specifically if it's against a hopper or any sort of inventory, if you start putting items into it, you see it actually starts sending out a pulse, but it's a very weak pulse, right? It only goes out to this first piece of redstone, which then I use a repeater to send that into this lamp here. But if I keep adding items, eventually the signal strength will increase. See how it went up to 2 and now 2 lights are on? And so if you just keep adding items, that'll gradually increase the signal strength. There's a certain amount of items that you need to put in to kind of go to the next signal strength. And that is kind of one piece that we're going to be using in this next component right here, which is called an item filter. Item filter. I hardly know her. So hoppers, they indiscriminately kind of suck up items, right? I could throw that in, I could throw that in, I could throw that in. As long as there's space in the hopper, it's going to take it up. However, sometimes what you want is for it to basically take in only one item, right? What if I want this to suck in hoppers, but I don't want it to suck in gray concrete? And that's exactly what this is accomplishing. So what we have here is we have a hopper that has what we call an item filter inside. I only want this to suck up hoppers, so I only have hoppers inside of this item filter. So I filled up all the slots so nothing else can go in, and then I have 18 right here. And the reason there's 18 specifically right there is because this comparator is kind of taking a signal, right? Remember, the comparator kind of gives us an idea of how much stuff is inside of this inventory. And as soon as I put in one more hopper, what's going to happen is that this signal strength of 1 is going to become a signal strength of 2 and power this block right here. But by doing that, what that's going to do is it's going to activate this repeater, which is going to carry on the pulse to this redstone torch. And remember, putting a pulse into the redstone torch, that turns it off, right? As soon as I activate this lever, the redstone torch goes off. So that's going to turn off this redstone torch. Now, why that matters is because redstone torches lock hoppers. So if this redstone torch locks this hopper, nothing can go through it currently. So I put a hopper inside of here, but it's not able to pump out the hopper into this chest because the hopper is locked because of this redstone signal on it. So what's going to happen now is I am going to throw a hopper into here, and because it's the same type, it's going to suck it up, but then it's going to make the comparator send out an extra strong signal, which is then going to turn off the torch, which is going to unlock the hopper and allow me to put that item through here. But as soon as that item goes through, this signal strength is going to drop back down again, and it's going to relock the hopper, which will maintain the amount of items inside of here. So if I throw this item in, we see it's still 18 in here, but the item went down here. And we kind of need this one extra item for a buffer just because it does get relocked. But now that we have that extra item in there, if I throw in a bunch of different hoppers, that's going to be unlocked. Then what's going to happen is they're all going to go inside of here, right? So that's the gist of it, how an item filter works. And of course, no other items can go in because they don't match the filter. All right. And one thing to note is that this is what is called tileable. So you can put multiple item filters kind of next to each other and they can accomplish the same thing. So this one is for gray concrete and this one is for light gray concrete. So you can't put either one in there, but you can put them in their own respective filters. And the reason this is tileable, because you might think, oh, these wires are going to get crossed here. Well, if these only output a signal strength of 1, then they're not going to be activating either of each other's repeaters because they can't get down here, right? So they're not going to be activating each other. And furthermore, when this goes up to 2, right, when I put an item in and that makes the signal strength go to 2, that can only travel down here or to the adjacent block, right? 1, 2, or 1, 2. So it can't actually get over here. So when this item filter is activated, that will not have enough strength to activate this redstone dust over here, so that means it's not going to actually activate the adjacent item filter. So that's why this design is called tileable, because you can put them beside each other and they're not going to influence each other. All right, so that's everything you need to know about item filters.
Automatic dropper.
So this...
I hardly know her.
This right here is called a dropper, and essentially if you put an item inside of it and then you activate it, it will shoot that item out. And if you just keep sending it pulses, it'll just keep sending the items out one after another. However, what if we want it to just kind of automatically spit items out as it gets them, right? And so this is what this device does. You can imagine kind of taking the hopper here and putting an item inside, and you'll see, yeah, it just kind of spits it out. So what's happening here? Well, this comparator is detecting that items are going inside the dropper, but because it's only a single item, right, the signal's only a strength of 1, just kind of like up here. So the repeater is going to basically amplify that, which then makes it a strong signal. So then the dust kind of goes over here, and then it's detected by these observers. And remember what the observers do. The observers detect updates, right? So when this redstone turns on, the observer detects that. But because this observer detected that, then the one above it is actually going to detect that this observer detected it. Then the one beside it's going to detect that this observer detected something. And then that's going to output a signal over to this hopper. But because it outputs what's called a strong signal, then what's going to happen is that the signal going to this hopper will transfer over to this dropper, and that activates it, which then shoots out the item. All right, so those are all the preliminaries that you need to know. And now we're going to actually get into the beast over here. So what does this thing do? So you might see a little thing in the side that says drops. What that is it's a scoreboard. And scoreboards, kind of part of command blocks in the game, which are things that allow you to like kind of manipulate the game at a much more technical level. A scoreboard is basically something that keeps track of some aspect. You could have a scoreboard for how many times you've died, or how many enemies you've defeated, or how many players you've defeated, something like that, right? So they're extremely customizable. And so what I've done here is I've made a bunch of different scoreboards. So the first one I've made is called the drops counter. And what this is going to do is it's going to count how many times we actually get flesh dropped. If a zombie dies and drops 2 flesh, this is going to count 2 flesh. Or if they drop no flesh, this is going to just kind of remain at nothing, right? So that's what this counter is going to do. And if you look inside, this is the command for it. So we use scoreboard, so that just means we're just using a scoreboard, objectives, and then we're adding a new scoreboard, which we're calling drops, and then the type of scoreboard is a dummy scoreboard, so it's not actually measuring anything in the game, it's just kind of a default scoreboard that we're going to be adding to and subtracting to manually. For example, if we had a scoreboard that was with deaths, anytime we die it would automatically be updated, but this one is one that we have to manually update. So that is that piece right there. And right above it, I have another command block that says scoreboard objectives set display sidebar drops. So this just means on the side of the screen, we're going to have drops being displayed. So whatever the number is, that's going to appear below the drops. All right, so when I press this button, that kind of activates both of those. And then this next part here is going to be called the zombie total. And this, once again, it's just another dummy variable that we're going to increment manually. And the exact same idea up here for the sidebar, just we're calling it zombie total. So then we have for no flesh, 1 flesh, and 2 flesh, the exact same idea. I'll get into why we have 3, 4, and 5 in a moment, but for the time being, let's just look at these kind of 5 components right here. So this keeps track of how many zombies, this keeps track of how many zombies had no flesh dropped, this keeps track of how many zombies had 1 flesh dropped, and this keeps track of how many zombies had 2 flesh dropped. So that is what these kind of different components are going to be doing. And up above, I just kind of have a reset line. So once we're done an experiment or done a trial, we can reset, we can undo any kind of values that have been stored. So it's just scoreboard, players, reset, and then you put your username there, and then you put drops because that's what you're resetting. And then if you want to reset the zombie total, it's the exact same thing, but you change what the name of the scoreboard that you're resetting is. So that's kind of all the command block setup that we need for the time being. So next thing we're going to do is we're going to look at this chamber here. So what this chamber is going to do is it's going to summon in a zombie, and the zombie is going to have half health. So if we look at this command block here, this says summon zombie, and then these are called relative coordinates, so it summons it at the location of the command block. So that's at the X corner of the command block, that's at the Y corner of the command block. Because I don't want it to spawn inside of the command block, I put -3, which means it's going to be 3 below the position that it normally would have summoned it at. And then right here, we are summoning it at the same Z coordinate. And then if we go over here, this part right here is just adding a tag, an NBT tag, to the zombie, which means that we're just modifying its characteristics and we're just summoning it with half a health. So it's going to die pretty much to any sort of damage immediately. And so when we summon it, it's going to fall down and it's going to die on top of that hopper there. And that hopper is going to basically suck up any sort of rotten flesh it drops. And it's going to, if you notice, it's the same design as over here, right? So this is going to essentially shoot out all of the rotten flesh into lava, which is just going to destroy it. But what happens is that every time a rotten flesh goes through, that's going to send a pulse to here. And as the rotten flesh gets destroyed, I'm also taking the pulse and I'm converting it over here, and I'm putting it into this command block, which says scoreboard players add, and then once again put your username, and then drops. So that was keeping track of how many rotten flesh drops there were, right? And then we're adding 1 to the score. So essentially, anytime this pulses, anytime a piece of flesh goes through, that is going to add 1 to the score here. All right, so that is kind of the first key aspect. Now, there is one slight issue with this, and that is that this is going to pulse 1 more time than needed, because when it pulses for a flesh, it also turns off, and any one of those turning off is also technically a block update, right? This detects when it turns on, but it also detects when it turns off. So if 3 flesh went through this system, it would basically send 1 too many pulses, and this would actually count 4 different items. And so to offset that, anytime we kind of summon a new zombie, I reset the drop score to -1. So normally we would have it at 0 and then it would just count up, but because it's always going to pulse 1 too many times, I have the drop score to be -1 just to make sure that that kind of gets offset properly, right? So if there was 3 flesh that go through, it's going to pulse 4 times. So then 4 plus this -1 will get me to the 3 that actually represents the amount of flesh that was dropped. So that's just my reasoning with this aspect there. And then the other piece of kind of this first part here is going to be, I also increment the zombie total, right? Because this is connected to the command block that summons a zombie. So this is going to be the command block that adds to my total of how many zombies I actually have summoned so far, right? So this is going to be just adding 1 every single time. Okay, so that explains this kind of trio of command blocks. So when I press this button to start the system, that's going to activate this triple of command blocks, and then it's going to kind of go through this clock here, which when I press this piston, that's just going to actually have the clock turned on. This just allows me to turn it off easily, because if I retract this piston, the signal can't go through. But when that's extended, this clock's going to go around, right? Remember, these repeaters just have a delay, so it's going to take a certain amount of time for kind of this circuit to complete. And when this circuit completes, that is going to summon a new zombie, reset the counter back down, and it is going to increase the amount of zombies that have been summoned. Okay, now it does split here though, and kind of before one loop completes here, I have a slightly shorter timer that goes over here to this trio of command blocks. If you remember over here, we have a counter for how many zombies drop no flesh, one flesh, or two flesh. And so what this is going to do is this is actually going to increment those counters. So right here, it's a little bit long, but it says execute, and then I have an if statement. So this is checking a condition here. So if the drops, so that's the amount of drops, matches -1, so that means nothing happened to increment the drops, right? So if nothing happened to increment the drops, then we're going to run this command here, which is going to increase the scoreboard for no flesh by 1. And remember, the scoreboard for no flesh is just keeping track of how many zombies didn't drop anything, right? So what this is saying is that if drops, which checks how many drops happened, matches -1, and remember we just had -1 to offset it, so that means no drops happened, then we are going to basically tell our counter that no drops happened to increment by 1. So that's what this one's doing right here. And then this one right here is the exact same idea, but is for keeping track of how many zombies dropped 1 flesh, right? So if the amount of drops matches 1, right, so they dropped 1 flesh, then we're going to run the exact same command, except now we're incrementing the 1 flesh counter instead of the no flesh counter, right? Because it was 1 flesh that was dropped to trigger this. And then lastly, the exact same idea, but for 2 flesh, right? So if the scoreboard for drops was 2, then we're going to run this scoreboard here, which actually adds to our counter of 2 flesh by 1. And remember, all these places where we see nuptial failures, just replace your username and it'll work just fine. So essentially, as the circuit goes around, it's going to summon a zombie. This is going to kill the zombie. This is going to count how many rotten flesh you actually got. And this is going to keep track of that. And this cluster of command blocks right here is going to actually increment the counters of if they had no flesh, 1 flesh, or 2 flesh dropped. And what that's going to do is that is going to allow us to keep track of how many zombies actually drop these. And we're going to actually test to see if it looks like it's true, if kind of all of these possibilities are equally likely or not. So that is kind of this first machine right here. You may notice that at the beginning I mentioned that zombies had a 2.5% chance of dropping iron ingots, potatoes, or carrots. And you may think this system doesn't account for that, and you would be correct. It doesn't account for that. And the reason it doesn't account for that is because these zombies, when they die, they're going to die from fall damage. They aren't going to be dying from being killed by a player. It's only when a zombie's killed by a player that it has a chance of dropping those rare items. And so this system isn't going to account for that. This system over here is going to account for that. It's a little bit more complicated. And the reason I kind of have it as a separate system is because there's also another aspect that we can measure when players kill it, and that is the looting enchantment. So looting is an enchantment that you can put on your sword, and basically when you kill an enemy, it increases the chances of some drops occurring. And specifically, for common items, it can give you extra amount of items. It can either give you no extra items, so you got unlucky, it could give you 1 extra item, or it could give you 2 extra items, or even 3 extra items. And so the way this works is that it adds kind of this amount to your probability depending on kind of the looting level. So for looting level 1, there's a half chance that it adds an extra item on. For looting level 2, there's also a half chance, but for looting level 3, there's only a 1/3 chance it adds an extra item on because it allocates some of that probability to giving you even better items, right? Like 2 items or 3 items added on. So let's go to a pen and paper real quick and calculate kind of what our expected probabilities would be for the zombie flesh drops. So here we can see that normally, without any enchantment on your sword, there's a 1/3 chance to get no flesh, a 1/3 chance to get 1 flesh, and a 1/3 chance to get 2 flesh. And then with looting, here's just the table copied down here. So we could either get no extra, 1 extra, 2 extra, or 3 extra, and these are the probabilities here. With it being more likely to get more extra items, the further down you go, the higher your level of looting is. And one thing to notice is before we could only get 0 to 2 flesh, but now since we can get up to 3 extra, that means we can actually get for anywhere from no flesh all the way up to 2 plus 3 or 5 flesh. So now we actually have to consider what are these probabilities going to be. All right, so NL means no looting, and then these are looting 1, 2, and 3. So for the no looting, there is still, it's still kind of as normal, right? There's a 1 in 3 chance to get nothing, a 1 in 3 chance to get 1, a 1 in 3 chance to get 2, and since there's no looting, we can't get any extra items, so 3, 4, and 5 flesh drops are impossible here. Alright, for looting 1, now we actually can have an extra one, right? So in order to get no flesh, we need both the normal flesh drop and we need the chance that no extra drops were added with the looting enchantment. So we actually have to AND these two events, and the way we AND two probabilities is we multiply them, right? We have to multiply this probability with that probability. And I have a whole video on why that's the case. If you haven't seen it, please go check it out. We're going to really need that in this section for ANDing and ORing two different probabilities. What's the probability of one thing and another happening, or one thing or another thing happening? So in order to get 0 flesh, we need this 1/3 chance to occur, and we need this 1/2 chance to occur, which is going to be a 1 in 6 chance that we get no flesh there. Now for 1 flesh, we have a couple possibilities. We could either get the 1 flesh from the normal section and then the no extra drop, or we could get no flesh from kind of the base drop and then an extra drop here, right? So we actually have two possibilities. So the first one is the 1 flesh and no extra, right? Because that still gives us 1. So that's 1/3 times a half, right? Because we're ANDing them. Or, right, the other possibility is we get no flesh and the 1 extra, because that still gives us 1 flesh in total. So the probability of that is also 1/3 times a half. And because it's one or the other, we have to add these two. And hopefully you're finding this really interesting, where we're actually getting to see in action using the AND and the OR rules of combining probabilities together. All right, what about 2 flesh? Well, 2 flesh could occur either by getting a 2 flesh in the base and no extra, or by getting 1 flesh in the base and 1 extra, like that. So we could have the 2 flesh, which is a 1/3 probability, and then no extra, so that's a half. Or, so we're adding, right? We could get the 1 flesh with the 1 extra, so that's also a 1/3 times a half. For the 3 flesh, this is also possible because we can get 2 flesh and the 1 extra, but that's the only way we're going to be able to get this. So we have to do the 1/3 times 1/2, which is a 1/6. And these two, I'm going to make another table with the simplified results just because we don't have much space here, but this is going to be kind of like our calculation table. All right, and there's no chance of getting 4 or 5 flesh, well, because with only the 1 extra possible, we cannot actually get to this amount of drops. All right, so I'm going to go a little quicker through looting 2 because it's the same kind of idea. So to get no flesh, we need none in the base and no extra. So that's 1/3 times a quarter, which is 1 in 12. So we see it's getting less and less likely to get no flesh dropped because, well, with looting, you want to get good drops, right? All right, with 1 flesh, we could either have the 1 flesh and the no extra, so that's 1/3 times a quarter, or we could have the no flesh and the 1 extra, so that's 1/3 from here plus the 1 or times the 1/2 from there, and that's the only possibilities. For the 2 flesh drops, now we could either do 2 flesh and no extra, we could do 1 flesh and 1 extra, or we could do 0 flesh and 2 extra. So there's 3 possibilities. So we're going to be adding 3 different kind of groups here. So for the 2 flesh and no extra, that's 1/3 times 1/4. And then for the 1 flesh and 1 extra, right, that still adds up to 2 flesh. We have 1/3 times a half. And then lastly, we're going to have no flesh plus 2 extra, so that's 1/3 times a quarter. For 3 flesh, we could either have 1 flesh plus the 2 extra, or we could have 2 flesh plus the 1 extra. So it's going to be 1/3 times a quarter, and then 1/3 times a half. All right, is 4 flesh possible? Yes, it is. If we get 2 with the base amount and then 2 with the added extras, so that's going to be 1/3 and the 1/4 probability, so we're multiplying them. And once again, we can't get 3 extra here, so it's impossible to get 5 flesh with looting 2. And for looting 3, I'm just going to kind of do it by myself, but I'll let you try and work out the reasoning behind this as an exercise. All right, so I've gone ahead and computed all of these. I encourage you to try it out for yourself as an exercise to try and get the same things that I got. Just one thing to keep in mind is remember order of operations. So that means we have to do multiplication before we do addition. So for example, if I was evaluating this section right here, I would do 1/3 times 1/4. I would do 1/3 times 1/2, and then I would add those two results together afterwards. But we've done a lot of practice with fraction addition and multiplication, so I'm not going to go through the nitty-gritty of it right now, but this is what your answers are going to be, so you can check your work when you've computed them. And one more thing to kind of know that we did this right is if we add up any of the rows, for example, a third plus a third plus a third plus 0 plus 0 plus 0, we're going to get 1 every single time. Because, well, 1 is 100%, right? And if we add up all of these and we get 100%, that tells us that we've written down all of the possibilities here. Because essentially for any trial, we're guaranteed to get one of these options, right? So when we add them up, it makes sense that we get 100%. And one more thing before we get back to the Minecraft world, because we're actually going to be killing the zombies as the player and we're not just going to be watching them die, we also could get the rare drops. So the rare drops, there's a base probability of 2.5% of them actually dropping. And then with each level of looting, it's going to be plus an additional 1%. So with looting 1, it's going to be 3.5%. With looting 2, it's going to be 4.5%. With looting 3, it's going to be 5.5%. All right, so this is also something that we will be able to measure. So now we officially have all of the different probabilities for everything that we're going to be measuring, right? We've got all the normal flesh drops, right? So when we're just going to be measuring it without actually killing the zombies, this is what it's going to look like here. And then in this table, these are the probabilities of our 0 through 5 flesh drops when we're using no looting, looting 1, 2, and 3. And then lastly, we also have the probability of the rare drops when we're not using looting and when we're using looting 1, 2, and 3. So now that we have all of these probabilities fully written out for us, we can actually go ahead and start testing to see if the results that we get are actually close to this. But first of all, let's go back and look at how the more complex machine works, the one that's going to be measuring the 0 through 5 flesh as well as the rare drops. Alright, so now we're going to be focusing on this piece right here, which is going to also measure the zombie drops. So for this, we have a couple of additional things. So in addition to the none, 1, and 2 flesh, we also have counters for 3, 4, and 5 flesh. So it's the exact same things, except now we're writing 3, 4, and 5. And then we are also going to have a scoreboard so that we can keep track of these additionally. And then we also have some resets for them as well, just like we did for the others, just so that we can reset the system whenever we want to. All right, so with that in mind, the way this is going to work is we're going to be standing right here on this pressure plate, and what that's going to do is when we're on top of that pressure plate, it's going to extend this piston, which is just going to allow this circuit to keep running. And then as soon as we get off, it'll retract the piston and it's going to stop the circuit. So that's when we're going to be basically concluding our trials. And the way the circuit goes is, okay, we're going to press this button, and that is going to activate this cluster of command blocks here. So this one summons the zombie, also with the 0.5 health, but it's just at this location inside of this tube here, so that it's going to drop down right in front of the player. This time it's not as far of a drop, so that we can actually kill them as the player rather than the fall killing them. And then we're going to have an addition to the zombie total counter, so how many zombies we've actually gone through here. We're setting the drops to -1, just like we did over there, just because this is going to do one additional count. And then we have kind of this longer timer here, just because it takes longer for this system to process things, as you're going to see in a second. So we have a longer timer here than we did over there. And then over here is going to be actually our counter. So this is going to count no flesh, 1 flesh, 2 flesh, 3, 4, and 5. So it's just going to increment based on how many drops that we end up getting. And the drops counter, that is over here. So it's the exact same setup as over there. This hopper is going to pick up the items. This right here is going to eject the items into this water stream here, right? So this is going to basically pulse every time an item goes through here. It's going to eject the items over here. And the items are actually going to go into a second hopper which is also going to basically eject the items. So that's going to eject all of the flesh into the lava section. And this is going to be the actual counter, right? So it's going to increment our drop score every time a flesh goes through here. All right, so that accounts for the flesh, right? This can basically pulse all the way up to allow us to have 5 different drops, which this cluster over here is going to count and then increment the scores respectively. So now the only piece we haven't talked about right here is these 3 different item filters. You'll notice that we have some item filters here, just as we talked about over there. So what these item filters are for is for the rare drops of the zombies, right? So that's either the potato, the carrot, or the iron ingot. Those can all be dropped from the zombies. And so I have 3 different item filters set up here. This one is set up for the iron ingots, this one is set up for the potatoes, and this one is set up for the carrots. So these are just all put together, and then we're just going to manually count how many, oh, there's one extra in there. We're going to manually count how many carrots, potatoes, and iron ingots we get afterwards. All right, so this is going to filter out the special items, which means we're going to only have the flesh over here. This is going to count that, and then this is going to interpret the counting every time one zombie goes through here, which is then in turn going to increment our systems here. So with that all being said, you guys should understand how all the probability works now. You should understand how both of these machines work now. So now let's get to the actual experiment. So written in this book, I've prepared everything that we're going to need. So for the natural death, so that's going to be using this one. We've got our expected values, so 1/3 chance for each of these. And then we're going to do 10 trials, 100 trials, and 1,000 trials and record how many flesh we get for each time. And by doing that, we're going to be able to get the relative frequency. And recall that the relative frequency is basically like our experimental probability. So it's going to be, for example, the relative frequency for 0 flesh will be how many times we get no flesh for zombies out of the 10 trials that we did. And so doing this, we're going to basically get kind of our experimental probability or our relative frequency for all of these trials. And what we should hopefully see, according to the law of large numbers, if you recall that, the law of large numbers said that the more trials you do, the more your relative frequency is going to start to look like the probability, eventually, ideally. We could get extremely unlucky, but that's pretty unlikely, especially if we do something like 1,000 trials. So what we're hoping to see is that the more trials we do, that these relative frequencies are going to look pretty close to the expected values that is coded into the game. So without further ado,
let the fun begin.
So I'm going to reset everything just to make sure we're all good. And then I'm also going to put it on zombie totals so that we can track that we're just doing 10 zombies right now for these 10 trials. All right, so let's begin. Alright, so that was 10 trials. Let's find out what our totals were. So for no flesh, we see we have 5 that got no flesh. Alright. For 1 flesh, 3 had dropped no flesh. And for 2 flesh, 2 dropped 2 flesh. So 5 plus 3 plus 2 is 10, so this does add up to the amount of trials we did. And so what we see then is that our total probabilities, we get our 5 and 10, which is the same as a half. We're going to get 3 and 10, and we're going to get 2 and 10, which is the same as a fifth. Alright, so not super close to these values, but not awful either. Let's go on to 100 trials now. Also, that took a long time, so what I'm going to do is I'm going to speed up the game by using the tick rate command. So tick rate, and then the default is 20, so let's maybe do 100, and that's going to allow these to go faster so that we can actually do the 100 zombies a lot quicker. So I'm going to select it back to zombies total. I'm going to reset everything, and let's begin.
Bruh.
Oh, oops, I forgot to turn that on. See, it's way faster now, right? Alright, so that was 100 trials. Let's see what we got. So we have 31 in the no flash, which is a 31 out of 100 relative frequency. In the no flash, we had 39, just 39 in 100. And at 2 flash, we had 30. So once again, these add up to 100, so that's perfect. And we can already see that these are actually getting closer to the expected values, right? This was like 50%, this was 30%, this was 20%, but these are all a lot closer to that 33.3 repeating percent of the 1/3 probabilities. So law of large numbers is looking like it's already coming in clutch here. Let's move on to the 1,000 trials. This tick speed command is like pretty new, so this is exciting. Alright folks, that's 1,000 trials. Let's see what we ended up getting. 348 no flash. 318 with 1 flash. And 334. Alright, and if we add these up, I think we're gonna get... Yeah, we get exactly 1,000. Awesome. Alright, so now let's quickly just write out what the percents are so we can actually compare them on paper. Alright, so I've written down all the percentages, and I think this will make it a little more clear. So here are true percentages, right? 1/3 is just 33.3 repeating percent. And we see with the 10 trials, we had 50, 30, and 20. So not super close, but not awful either. For 10 trials, we got a lot closer, right? With 31%, 39%, and 30%. And with 1,000 trials, we got even closer, with most of these being quite close, especially with the 2 flash. That's like extremely close, 33.4% versus 33.3 repeating percent. So we got a lot tighter around the true values with the more trials we did, which is what we should have expected with the law of large numbers. And it does seem that these probabilities are accurate. It's pretty close, right? So awesome stuff here. And let's go on to the player kill stuff now. So what we're going to do is we will do 10 trials, 100 trials, and 1,000 trials. We're going to do no looting to start with. These are our expected values, and we'll see how close the probabilities we actually get to this. All right, so that was 10. Let's see what we get. So we've got 4 results for no flash, 5 results for 1 flash, and for 2, that would probably be just the 1, yeah. And since we didn't use any looting, we should expect nothing for 3, 4, and 5. Yep, so that looks good. And then let's see if there were any special drops. Doesn't look like it, so no special drops. That makes sense, it's pretty rare to get this, so it's such a small amount of trials, we wouldn't expect to get much. Let's boost it up to 100 trials now. Alright, so that was 100. Let's see what we got. Start with the no flesh. We got 35. For 1 flesh, we've got 40. So that puts us at 75. So hopefully we'll have 25 for the 2 flesh if it all adds up properly. And we got 25. Perfect. And then these remaining 3 should be 0 once again because there was no looting. Yep, perfect. It's always exciting when these things work. Alright, and then rare drops. Let's see if we got any. We got 1 iron ingot, 3 potatoes, and 1 carrot. So in total, that is 5 different drops. Alright, it's time for the 1,000. Hope I don't screw this up. Alright, so if we look at the no flesh, that's 337. 1 flesh, that is 366. 2 flesh, that's 297. And the rest should be 0. We'll check in a second. Yep, perfect. And if we add these scores up, 337 plus 366 plus 297, yep, we get 1,000. Awesome. And then for rare drops, 5, 7, so that's 12, plus 11 is 23. All right, groovy. So that concludes our trials for the no looting and for the player kills. So let's look at these on a piece of paper. All right, so I've written down the values here. So the true values, once again, were 33.3 repeating percent for the flesh, and then 2.5% for the rare item. So for the 10 trials, we see that, as expected, we're pretty off. I mean, the rare one indicates that there's no chance of getting it right, but again, these are just our relative frequencies. So for a smaller amount of trials, they're going to be more off. And we do see that in general, for the more trials we do, we get closer to these true values. I think these ones were a little worse off than what we did for the previous test. Yeah, if we look at our 1,000 trials for the natural deaths, we got a little luckier here where these values, I would say on average, matched the true values a little bit better. It is ultimately kind of random chance, right? But our rare drops, that percent matched pretty closely to the true value. So that looks pretty good. All right, so now let's go on to do this with looting 1. All right, so for looting 1, these are our expected values. We can actually get 3 flesh this time, so we'll be expecting some action with that. And we have a slightly higher chance of the rare drops. So let's start with the 10 trials. I've got the looting 1 sword here. For the no flesh, we've got 3 no flesh. For the 1 flesh, we've got 3 as well. For the 2 flesh, we've got 1. For the 3 flesh, we've got 3. And then 4 and 5 should have nothing. Yep. Alright, let's see if we got any rare drops. Doesn't look like it. Perfect, so that's 10 trials. Let's go on to 100. And let's get started. So we've got 10 in no flesh, 47 in 1 flesh. For 2, we've got 34. And for 3, we've got 9. Let's see if these add up to 100. 10 plus 47 plus 34 plus 9, 100. Perfect. And for 4 and 5, nothing. Good. And now let's check out rare drops. 3 iron, 1 potato, and 1 carrot. So that's 5 rare drops in total. And make sure to empty these always afterwards. Otherwise, that's going to influence your next event. And then these will be dependent events, right? Because you're going to be influencing what you get in the next one. All right, perfect. Let's go on to the 1,000 trials for this. Alrighty, so we just did 1,000 trials, and now to see the big results. So in no flesh, we have 181. In 1 flesh, we got 359. In 2 flesh, we got 360. So extremely close with these two. And in 3 flesh, we got 100. And since this was looting 1, 4 and 5 should both be 0. Perfect. Alright, and if we add all these up, let's see if we get 1,000. And we get 1,000. Awesome. That's the Bowmath's difference, baby. And let's check out our rare drops. We got 11 iron ingots plus 18 potatoes, so that is 29, plus 15 carrots, so that is 44. So we had 44 rare drops. Alright, awesome. So now that we have all this in mind, we can go to the table and actually compare our relative frequencies to the probabilities. Alright, so I filled out the table here with all our percentages. So for the 10 trials, relatively inaccurate, right? 30% is way different than the true value of 16.6%. For the 1 flesh, though, it was pretty close, right? But yeah, as we can see, relatively inaccurate, then slightly more accurate for the 100 trials, And for the 1,000 trials, it's even more accurate. But you might notice that these values for the 1,000 trials, in general, were less accurate than the values up here. And one reason for this is because we're measuring more things now, right? Before, we just had 4 different kind of options that we were working with. But now we're actually measuring more things, right? And so as we're going to see with looting 2 and looting 3, it's probably going to be the case where our 1,000 trials are going to be a little less likely than the previous ones, but of course still more likely than the 110 trials within their respective categories. But in any case, we do see that our 1,000 trials, as expected with the law of large numbers, is relatively close to the true values. Alright, so let's move on to looting 2. Alright, so here are the expected values for looting 2. We can get up to 4 flesh this time because looting 2 allows you to get up to 2 additional items. And our rare drops are now at 4.5%. So let's start doing these trials. Alright, so we've got my looting 2 sword here, and we're about to do 10 trials. And then for the 100 and the 1,000 trials, I got sick of clicking, so I have now downloaded an auto clicker, which will just automatically click for me, so while I'm waiting I can go and do some other stuff. Alright, so let's start with the 10 trials. So that was 10, let's see what we got. So for no flesh, we've got nothing. Ooh, that is possible. For 1 flesh, we've got nothing. Oh man, also possible. For 2 flesh, we've got 3. For 3 flesh, we have 7. So that's quite a lot. And for 4, I guess we should expect none because we've already gotten 10. Yeah, nothing for 4, and then 5 isn't possible yet, so notice it's getting less and less likely to get lower amounts because the looting level is going up, right? Let's see what we get for the rare drops. Oh, 1 carrot, alright. Alright, groovy, let's go on to 100 trials. Hey everyone, Future Bowmaths here. Just so you know, with this trial, I actually had to do multiple goes. And I figured I'd explain to you why, because A, you'll understand the process a little better, and B, if you're trying this out for yourself, maybe you could save yourself a little bit of heartache. Alright, so to demonstrate this, I'm going to raise the tick rate to 400, and I'll start killing some zombies. Alright, so it looks like I'm killing them, every single time, right? But we're going to see an issue right away. Alright, so that's good enough. So there were 41 zombies in there, right? And we would expect then our numbers to add up to 41. And since I didn't use any looting, it would only be within 0, 1, or 2. Let's see, so we have 17 plus 15 is 32 plus 5 is 37, which is not 41. So where did those extras go? Well, look what happens if I press these. Oh, I get something for 3 flesh. Oh, I get stuff for 4 flesh. Nothing for 5, but 3 and 4 definitely should not have happened, right? Because I wasn't using looting. So what explains that? Well, the key is to note this timer here, right? So with this timer, the timer gives enough time for this system to process the items, right? But let's say I kill a zombie while the timer's like already over here. There's not going to be enough time for the system to finish processing the items before the next zombie spawns. So even though it looks like I kill the zombie before the next one spawns, that doesn't give the system enough time to process the items. So really I need to kill the zombie within the first few ticks here. Otherwise what's going to happen is that some of the flesh from the previous zombie is still going to be getting processed while this new zombie gets summoned in. And so that can result in is that multiple zombies' flesh can kind of get clustered into one, and then this system doesn't know the difference, right? And so let's say one zombie drops 2, the next one drops 2, and the system doesn't process that in time. That's how you could get something like 4 flesh occurring, right? Where it's just the result of multiple zombies drops because I killed it too late. And so this is a hard thing to control if the tick speed is too fast and you're not clicking precisely enough. And so when it comes to using the auto clicker then, you have to find the right combination of the auto clicker's speed as well as your game tick speed. So one combination I found that worked quite well was having the tick rate be 120 ticks per second and having the auto clicker speed being every 100 milliseconds, or every 10th of a second is when that could occur. All right, so now that you understand how that works, I encourage you to experiment with some different combinations to try this out for yourself. But without further ado, let's resume the experiment. So in no flesh, we've got 7. In 1 flesh, we've got 19. In 2 flesh, we have 49. For 3 flesh, we've got 21. And for 4 flesh, we've got 4. Nice. And nothing in 5 flesh as expected. Okay, so let's see if these add up to 100. They should. Yep, I get 100. Perfect. And now let's check out the rare drops. Got 3, 4, 5 in total. Man, I think we've had 5 on like all of the 100 trials so far. Alright, 5 rare drops. Let's go on to the 1,000. Alright, so for no flesh, we got 77. 1, we've got 255. For 2, we've got 383. For 3, we have 255. For 4, we've got 30. And for 5, we should have 0. Yep, perfect. And let's add it all up to make sure it's 1,000. It is indeed. Awesome. And now for the rare drops. We've got 13 iron, plus the 19 potatoes, plus the 21 carrots, so that's 53. Definitely a heftier amount of rare drops this time around. So now let's put this in our summary table. So here's our summary table of our relative frequencies. So once again, for the 10 trials, pretty inaccurate, right? Really high rare amount. A lot of these were 0%. For 100 trials, a bit more accurate, right? It's definitely closer values now. And for 1,000 trials, even more accurate. Most of them got a lot closer. One thing that I thought was interesting was that both 1 flesh and 3 flesh, they have the exact same probability, true probability of happening, and we got the exact same relative frequency, which was extremely close to the relative probability, so we lucked out there a bit, and everything else kind of looks normal. Alright, so let's go on to the very last looting level, and then we'll give some concluding thoughts, and that'll be it for today. Alright, so for looting 3, here's our expected values. We have a much smaller chance for the lower amounts, but a decent chance for higher amounts, and we can finally get to 5 flesh this time, so we're pulling out all the stops, we're measuring all of these different values. In addition, we're going to be having a higher chance of rare drops at 5.5%. But once again, because we're measuring more things, we should probably expect the 1,000 trials to be slightly less accurate than some of the previous ones we did, like the 1,000 trials for the looting 1, for example. Alright, so over here I've got the looting 3 sword, and let's get started. Alright, so that was 10, and let's see what we got. Nothing for no flesh, again, smaller probability this time. 1 for 1 flesh. 6 for 2 flesh. 3 for 3 flesh. Nothing for 4 flesh. And nothing for 5 flesh. So we had our 10 events in total, and we should check our rare drops now. Nothing, nothing, and nothing. So 0% for the rare drops. So despite the fact that there is an objectively better chance of getting rare drops with looting 3, because we did such a small amount of trials, it just wasn't really reflected here. If we relied on such a small amount of trials, then for the looting 2, right, we actually might have thought that we had a better chance of getting rare drops, but again, it's kind of inaccurate because we're using a relative frequency with a small amount of trials. So you got to be careful with that. Moving on to 100 trials. Those are 100 trials. So for no flesh, we've got 3. For 1 flesh, we had 12. For 2 flesh, we had 41. 37 for 3 flesh. 6 for 4 flesh. And a measly 1 for the 5 flesh. Alright, and let's add these up. 100, baby. 100 all the way. So these add up to 100, so that means the system worked. And for the rare drops, let's see what we got. 2 plus 1 plus 1, so 4 drops in total. Alright, here we go. Last set of trials. It's the final trial. Do-do-do-do. Subscribe to Bo Maths. Do-do-do-do. He is pretty cool. The final count. We've got 46 for no flesh. For 1 flesh, we've got 175. For 2 flesh, we've got 361. So, it's a lot. For 3 flesh, we got 350. Very similar amount. For 4 flesh, we've got 66. And for 5 flesh, a measly 2. Wow. Okay, that's quite a small amount. So I think that's a lot smaller than what the probability is actually supposed to be. But again, this is just relative frequency. It's very possible to get things that aren't super accurate to the amount. Again, 1,000 trials is a lot, but it's also not that much. If we did 10,000 trials or 100,000 trials, we should expect this to be more likely to be more accurate to the probability. Now let's see if it adds up to 1,000. It does indeed. All right, awesome. So now let's just look at the rare drops. We got 12 iron, 16 potatoes, and 17 carrots. So that's going to total to 45. So that is our last test run of this experiment. Aww. Let's look at the table. Alright, so here's our last table for the looting 3. So as we can see, for our 10 trials, somewhat resembles the true probabilities, but again, pretty inaccurate. Similarly, for the 100 trials, it definitely moved towards a more accurate picture, right? We definitely see that for the smaller probabilities on this table, we get a reflected small probabilities, and we get slightly more for the 2 flesh and the 3 flesh, which have the highest probability of occurring. And then for the 1,000s trials, it's even more accurate. But again, because we're measuring a lot of different things, we're measuring 6 different things here, that's going to get spread a lot more over the 1,000 trials. So our relative frequencies are going to be a little more coarse than the previous ones that we did. For example, I'd say we got really unlucky with the 5 flesh drops. There was only a 0.2% frequency of them with our relative frequency, whereas it's supposed to be a decent more frequent than that, right? If we wanted to figure out of the 1,000 how many we would have expected to have actually occurred, all we have to do is take our 5.5% and actually multiply it by 1,000, right? So 5.5% is 0.055, and then multiplying it by 1,000, we would have expected to have had 55 zombies that dropped the 5 flesh. However, we actually had 2, so we got pretty unlucky in that circumstance. But again, this is all relative frequency, not the probability. I should note that I was a little bit biased in this situation just because I saw 2 flesh and I thought, oh, that's such a small amount, so that's got to be the worst one. And well, the math I just did was completely accurate, right? There was even a worse relative frequency that I completely glazed over, and that was for the 4 flesh. The true probability would have been 16.6 repeating percent, but the relative frequency we got for the 1,000 trials was only 6.6%. So that's actually pretty low. That's a little bit over 10% off. So if we want to talk about getting unlucky, the 4 flesh, I think, was the one that got shorthanded the most. Alright, well, I hope you found that video interesting. I had a ton of fun making it. It's really interesting kind of just thinking of a problem, coming up with some sort of machinery or experiment in order to actually work through the problem and, see what happens and to see the kind of the theoretical math you work on, how that can be translated into some real life stuff, I think is always quite satisfying. So I hope you enjoyed it. And, some of the main takeaways from this are, of course, that relative frequency does not always match probability, but we saw with the law of large numbers that the more trials you do, the closer it's going to look to your probability. And we saw that pretty consistently today, I would say. If you're interested, I kind of made a tutorial on how this all works, so feel free to try and build this for yourselves. I mean, I'd be really interested to hear about, people doing this for different mobs with different drops and different kind of loot tables, and just kind of seeing what people do with it. Of course, I'm no expert at redstone stuff, so I'm sure this could have been made maybe a little bit more efficiently than I did. But in any case, I hope that you found this enlightening, and yeah, that's gonna do it for me today. So until the next video, you have a good one, you stay groovy, and I'll see you in that next Bo Maths video.